Hello everyone, welcome back to another video in our second unit on EDA. In this video we're going to be talking a little bit more about missing values in pandas. So here I just have a sample data frame uploaded. So we can see here I have columns A, B, C, and A has a bunch of numbers, but then there's also these question marks. B and C also have numbers. Notice B has no question marks. C does have a question mark, excuse me. So kind of in this example, the question marks are supposed to represent missing values, but the issue is that Pandas doesn't know that. It doesn't know that the question mark means this is a missing value, and in turn this is going to cause a lot of problems for us. So let me kind of show you an example. So let's say I wanted to take the sum of all of the elements in the A column. So I could say df of A dot sum, and notice the data type before I run this. Of A, it's saying this is object, so we should think string. So what's happening is these question marks are strings, so it's interpreting everything else in this column as a string as well. So .sum is going to give us something called string concatenation. So what it's doing is it's taking 3, then 2.1, and it's basically combining everything into one long string. So to show you an example of kind of how else this works, I could do something like 15 plus, let's do 15, and if it's in quotes, so this is going to return 15, 15. So it kind of smushes the two strings together. So this is called string concatenation, and that's what's happening here with df of a dot sum. So again, I could look at the data types. It's already written here, but just as a reminder, I could say df dot dtypes. And it's saying A, it's saying object, so it's thinking strings in this case. Same thing for C, but B is better, so it's saying everything in B is a float, so I could do the same thing and say instead df b dot sum, and this will actually just sum up all of the entries in B. So another thing I want to show you is, remember, df.describe, this returns information about the distribution of numbers in each column, in numeric column, but in this case there's only one numeric column, right? Or at least Pandas thinks there's only one. So it's only returning information about B, even though both A and columns A and C have numbers and it's supposed to be numeric data. The question marks are really throwing everything off. So just give me one moment. I'm going to turn a page in my notes, so that's what the sound is. So like we said, the issue here is that Pandas doesn't know how to interpret these question marks. So what we can do instead is we can just, when we import the data frame from the CSV file, we can specify that the missing values are represented as these question marks. So what I can do is say df, let's do 2, equals pd.read underscore CSV. This is called sample data. And let me see, I want to make sure I get the capitalization correct. Yep. So sample data.csv. And then what I can do is I can say NA values underscore values equals, and then I tell Pandas what are the null values represented, the missing values. This is question mark. So that ran without error. Now let's take a look at df2. So notice now where there used to be question marks, they got replaced with NaN. So that stands for not a number. And, oh, sorry, that's my cat. So what I could do now, let's just make sure everything works. We can already see that A and C, the data type changed to floats, but I could do df2 of A dot sum. And we can see this actually returns a number. I could do df2 dot describe. And notice now I get all 3 columns, whereas when we first imported the data frame without specifying the NA values, we just got the B column. Hello everyone, I'm back. I had paused the original recording to give my cat some attention. She gets very jealous when I record videos. And okay, so where were we? We had just finished talking about df2.describe. We saw how we now have columns A and C added, that we've kind of told Pandas what the missing values were represented as. I want to end the video by showing you, well, one, how could we access this NaN value? And the way we do that is by going through NumPy. So I'm going to say import NumPy as NP. And the way I can access NaN is just by saying np.nan. And what we can do is I can say, well, what's the type of np.nan? And it's saying float, so we can think of NaN, this not a number, as some fixed float. And in practice, it represents missing values and also undefined values. So, okay, if we go back to df2, we can see here in location 2, a, we have this value. So let's kind of pull it up. So I can say df2.lock 2, a, and it's saying here this is NaN, not a number. So that's good. Now something surprising that might happen is, what if I said, is this equal to np.nan? And this is going to return false. Maybe even more surprising, watch if I do np.nan. Can I ask, is this equal to np.nan? And this also says false. So what's happening here is, or maybe the short of it is, you never want to check for equality using double equals with np.nan. So that's why in the previous video, if I wanted to drop the rows that had missing values, what I would do is I'd say df2.drop na. And what that would do for me is remove the rows with missing values. So I think this is a good place to stop the video. Thanks for watching, and I'll see you in the next one.